So I've been going over some basic use cases for MCC in MPLAB extensions for VS Code. Let's have a look at some of the new workflows. But first, refreshing what we are used to. Creating a new MPLAB project. For a device. Now we just wait for build, CMake and output files to show up before we can open MCC. New configuration inside the project, default values. Okay, now we have this new MCC configuration associated already by default to this project and the default configuration. And if we look at the project configuration file, we have a default configuration with a default file set, and the file set is empty and we can generate code. We have some files associated with the project, and we can build the project. All good. Okay, so let's close this folder and start with some of the use cases which are now new. No project open, MPLAB, MCC. Now note it's actually possible to create an MCC configuration without a project. Standalone. It's not a project I'm creating now, I'm creating the MCC configuration. I'm going to use an I2C proximity sensor as a way to show off different project configurations, and I'm going to start with the polled printf configuration of this particular example. Q43, custom location. I'm going to be in a workspace level, and I'm going to create an I2C proximity sensor folder, which is going to end up being the workspace folder. So I2C host example, and here you can see an overview of the different examples. If I wanted to get a sense of what each of these do, here I can see some GIFs, and here we're basically finding a list of devices which get an ACK when we look through, and we can build up a list of the I2C devices on this board. Here we have basically an LED chaser with the one I/O expander. Here we are looking at inputs from one I/O expander and using the outputs on the second one. And here is our use case for the proximity sensor. We have three different configurations represented here, which will be our use case. So printf, data streamer, and DV runtime. If you're new to DV runtime, we can show you the user guide, and here's an overview video. And think about it like when you're debugging with breakpoints and you set a watch on a variable. DVRT means that you can find the symbols of the variables that you want to watch in the ELF file and just view those at runtime. It's awesome. Anyway, it's just a use case for us now, and for now we're just going to select the proximity sensor, polled printf. We're going to create a pseudo configuration because all we want to do is add the high-level components so that we can focus on the configurations. There'll be a separate video which builds all of these up from scratch. So here we add I2C host, we add a delay, and we add a UART. Okay, here's our first pseudo configuration. You can see it's not associated with a project. That shouldn't be surprising because we don't have a project. So let's MPLAB create new project. So this is going to be I2C prox sensor project, just to not be confused about what this is. Custom location, workspaces, and we're going to create it at the same level, basically our workspace folder. Now we should be able to run a new command and associate this configuration, the polled printf configuration, with this new project. So Control-Shift-P, MPLAB, MCC, and we've got this new command we haven't used before, configure associated project. And now we first select the configuration to associate, so we only have one, so it's this one. I'm going to add it to this prox sensor project, and the default configuration is added because we only have that one configuration. Okay, and if we have a look inside our project, we have no files. Remember, this was the default file set. So now if we generate code, we have our polled printf configuration associated, and this should allow us to build now. MPLAB cmake build. There we go. Okay, first configuration. Now let's go and add a second one. So I'm going to close MCC. Also, this is the project, so I'm going to move this around. Yes, MCC would crash if it was still open as you start moving things around. MPLAB, MCC. So we're going to launch and create a new config. It picks up in the workspace that we already have this polled printf configuration, but we want to create a new one, standalone. We'll call it I2C callbacks data streamer Q43 custom location at the workspace level. So what we're wanting is that the different configurations at that kind of symmetrical level. Okay, so new configuration. It's not associated to a project, so we're going to need a new project configuration to associate this to. So we can come in here, but we can see that here we actually have the ability to use a GUI. Very few places in MPLAB extensions for VS Code. So this first one was I2C proximity sensor. So we rename the basic configuration and add a new one. And we're going to call this callbacks data streamer. Okay, so we have two configurations. So we have polled printf data streamer, and file set is config1 files, is config1 files. So it starts off as kind of copying the existing configuration. This is not surprising because it is the MPLABX behavior, and so when you create a new configuration of an MPLABX project, it kind of copies your existing one and then moves on from there. So we're going to just delete these files because we're going to create configuration for this new use case of the callbacks data streamer. As before, proximity sensor now interrupts with callbacks, now data streamer, and the main difference here is that yes, I2C host, then we have a timer, and now we use the data streamer. Okay, so here's our pseudo configuration. I'll handle the full configuration in a different video. And now we haven't associated this configuration, because we're in the callbacks data streamer, we haven't associated this configuration with anything. So let us do that. MPLAB, MCC, configure associated project. Well, first select the configuration to associate, so it's the callbacks data streamer configuration. We're going to add it to the proximity sensor, callbacks data streamer configuration. And there it's added. So now, when we generate code, here's our callbacks data streamer, and we should be able to MPLAB make build the data streamer configuration, and there we go. Okay, that's it for this video, but in the next one we're going to go on and we're going to show you how you can copy and paste whole configuration from some files and how we work with that.